Hi, my name is Nagarajan Sridhar. I'm the marketing manager for Silicon Carbide Gate Drivers in Texas Instruments. TI is excited to show you a solution where we are here to reduce carbon footprint using silicon carbide gate drivers towards driving silicon carbide in these systems. Bottom line, we are trying to reduce the carbon footprint. Here I am showing power extracted from the solar panel down into a 10 kilowatt solar inverter, which goes through a charge pile and further down towards charging the battery in the car using an onboard charger. I'm showing here the AC/DC part of the onboard charger. This one is a 6.6 kilowatt, and here is a 10 kilowatt inverter. First off, both of them have silicon carbide. Secondly, we have to drive the silicon carbide very effectively. I talked a little bit about this in a podcast that was discussed last week, and it is out there live, where I spoke in depth on the value of silicon carbide and how you need to drive silicon carbide using the right gate drivers. First off, silicon carbide and the ecosystem is key towards making all the solutions compact, highly efficient, and robust. And so what you're seeing here is these two solutions, both of them have very high efficiency. This one is driving at 50 kilohertz at 99% efficiency, and here you have the onboard charger at greater than 98.5% efficiency at 100 kilohertz. Now, I kind of highlighted a little bit on the switching frequency. That's the value of silicon carbide. You can drive this at much higher switching frequency compared to IGBTs, which is limited to no more than 20 kilohertz. So what does that mean at a system level? This means that you can actually reduce the size of your components, primarily the passives. And therefore, you can see that if I were to take, for example, the solar inverter, if it were to be using IGBTs, this would be twice the size of what you're seeing here. Likewise, the same thing out here. So you can see upfront the value of having silicon carbide in both these solutions. Now, you can also see the gate drivers that I'm pointing out here. TI's gate drivers offers different options. Here you are seeing a single channel isolated gate driver, and here you are seeing a dual channel isolated gate driver. Now I use the word isolated, and what that means is that for such high power levels, and typically for silicon carbide, one needs to have built-in isolation. TI has a proven capacitive isolation technology, and that has an industry-leading lifetime and very high working voltage of 1.5 kV. The other thing is all these solutions typically need reinforced isolation, and that means it can go up to, we can go up to 12.8 kV surge, and that's one of the industry highest values. So isolation is one thing that is needed in a driver. What else? I already talked about silicon carbide being a very high switching speed compared to IGBTs. That means your drivers need to have a very fast response time. And that is very important because you have to have, if you detect any problems such as any protection that you need to react fast. For example, this single channel driver has built-in protection features such as a desaturation and also a few other features such as Miller clamping. That is very important to detect these protection features and the time to detect very shortly. The other thing is this one, the driver that you see out here is a dual channel driver. This is key because first off, as you can see here, you have two drivers in one integrated circuit. That means it can be very compact. You can make the whole thing built in a manner such that the whole thing can be very compact, the whole board space. The other thing is, since our drivers are so fast, the channel-to-channel skew is very small. That means they can run at very high efficiency. What I would like to also highlight is that all these drivers, besides giving you these features, we have a wide variety of drivers. It's a very wide portfolio that we have. And if you go to ti.com/SiC, you'll be able to see all the details of these drivers. In terms of our isolation, if you go to ti.com/isolation, you can get all the technical details of our capacitive isolation technology.